It's not a collapse. Here's what's going on. When we did the original design,
Uh-huh.
we estimated that we might see 256 networks in the whole world. And
200?
256.
Okay.
Well, networks were expensive to build then. I mean, they were national scale things. So we guessed, remember, this is an experiment. We didn't even know if it was going to work. So we said, well, maybe 256 networks, and maybe, something on the order of 16 million computers on them. Remember, again, the computers that were part of the internet, and before that, the ARPANET, and before that, just in the universities, were great, big, expensive devices that were shared by hundreds or thousands of people. We didn't have personal computers, we didn't have mobiles, we didn't have laptops,
iPad.
we didn't even have desktops or iPads or notepads or notebooks or
Oh.
anything. So we thought
Video games.
these were all machines that were shared by a lot of people. So also, since we thought this was an experiment, we figured, well, um, 4.3 billion terminations should be enough for an experiment.
Mm-hmm.
Now the problem is the experiment didn't end. When
Okay.
we turned the internet on officially,
When? What is it?
January 1st, 1983.
1983?
1983.
This is
internet
really
turned
in on internet.
We turned it on in 1983 with the IP version 4 32-bit address space. And that address space lasted until 2011. And in 1992 or so, we all realized that we might run out of that address space. 1992 is almost 20 years ago. We designed and standardized the IP version 6 address format, 128 bits of address space. So in 1996, we had a new packet format that had this big address space, and we tried to encourage people to implement that in parallel with IP version 4.
Okay.
But very few people did. So, because they said, well, we haven't run out of IP version 4 address space, so why bother wasting time on this bigger address space? Now we've run out as of February of this year, 2011.
Okay.
There is no more IPv4 address space from the Internet Assigned Numbers Authority, and the Asia Pacific Network Information Center has actually run out of its IP version 4 addresses. And others like LACNIC here will run out maybe next year or the year after that. So it's time to implement the other big address space with the new packet format.
Mm-hmm.
But we have to do them in parallel. We have to run them both at the same time. We can't just turn a switch. It's because there are probably up to 2 billion devices on the internet, and we can't get them all to change all at the same time.
Okay.
So it's going to have to be an extended period of running with both protocols, version 4 and version 6 together. So we'll,
You need
we will get there.
the IP4 is ended.
Yeah. Well, I'm not going to run out of IPv6 address space until after I'm dead, I'm pretty sure, because it's got, 3.4 times 10 to the 38th addresses, which is the size only a geek would appreciate. That's 340 trillion addresses.
Okay.
That's selling of IP version 4 address space
Selling?
in a bankruptcy sale.
Uh-huh.
It was $11 per IP address. And, my first reaction was this is probably a bad thing because we don't want addresses to be treated as property. There's a reason for that. If you treat it as property and people buy and sell these addresses, every time they get transferred to someone, you have to reflect where those addresses are showing up in the network.
Okay.
The routing tables have to inflate in order to keep track of where an address is physically connected to the rest of the network. So this is a particularly bad thing to have happen. Some people say if the cost of the IP version 4 addresses goes up big enough, everybody will say, I won't buy them anymore, I'll switch over to IP version 6.
Mm-hmm.
But we still have the problem that some people are still running the old IP address space and they don't have IP version 6. So there's a collision
Okay,
there.
I know.
This is motivation to just get everybody up on IPv6 and then you don't have to worry about it anymore. None. Bob Kahn and I, when we did the design, did not patent it.
Do you have any copyright to this?
No, none. That's a different thing. We were doing the work for the Defense Department, but we knew we wanted this to be an international standard.
Mm-hmm.
And the only way that was going to happen is if it were freely available, because we didn't want the people running proprietary networks like IBM's SNA or Digital DECnet to refuse to use the internet protocols because they had some patent limitations or patent licensing requirements. We didn't want them to have that excuse to not do it. So we said it's freely available. Anyone who builds it can use it and connect it.
Okay.
And we hope that that would be enough to cause an international standard to emerge, and indeed that's exactly what's happening.
Okay, I understand.
Yes, I do, and I think the company is still trying very hard to stick with that as its primary motto. You understand that our purpose in life is to organize the world's information and make it accessible and useful.
Mm-hmm.
And we are really committed to trying to do that. It turns out that not everyone wants the information to be widely accessible, and so there's some tension sometimes, like with the Google Book scamming that goes on. But the founders of the company, who are still running the company, really believe that don't be evil is an important part of our privacy. Is an interesting thing because we go out of our way to protect people's privacy.
Okay. Catching.
Caching is there to make things more efficient.
Okay, I know.
That's all it's for. We are keeping track of queries and responses, and we use that to refine the algorithms that are used to search and respond. But we're actually not interested in individuals. We're interested in patterns that people make. We don't record who you are. We record some of your patterns. We don't share any of the information with third parties.
But you're sharing with the government in the United States.
Well, only if we are given a legal court order.
I know.
Of course, we have to do that in every country in the world, including
only
Chile.
in the United States.
No.
In Chile.
In every country where a legal demand from a court order appears,
I know.
we need to respond to that. Now, we don't sell any of the information to third parties. We use the information that we gather to try to figure out which ads you might be interested in. We don't sell the information about you or your behavior for the advertiser. We use the information to help the advertiser reach to deliver an ad. There we were primarily talking about policy. Although I have to tell you that the president of the Senate is a physician, as you know, and he's intensely interested in science and technology and astrophysics and everything else. And so a big part of the conversation was about that. It was about his interest in gathering information about people's health, about being able to analyze this information and understand more deeply the health of the citizens of the country, trying to understand trends and detecting where there might be an epidemic or other things like that. So he's very interested in the way in which online technology could help him with those kinds of policy questions. We also wanted to talk about government policy for open access to the internet, to encourage new businesses to form, to allow people to invent new applications, which is something that we've seen in the U.S., which is actually quite important. People are able to build new applications without having to get permission from every ISP. And that's important for new business invention.
I know.
Will you please, as government official, will you please
promote use to IPv6?
Not just promote. I said, please go to the internet service providers in Chile and ask them, what is your IPv6 plan, and when are you going to have it released?
Do you
think that it has to be a law? I think that people will do this partly as they are persuaded that it needs to be done, but it's not on the radar screen.
I know.
Until somebody in authority asks. They're saying, well, my customers are not asking for this. I want the government to be the customer saying, I want IPv6. When is it going to be available?
Okay.
And at some point, they have to wake up.
Okay.
And figure out.
It's a very important thing. It's a very important topic for this technology.
It's a hugely important topic. Here's the problem. Some people say, well, I didn't run out yet.
Okay.
And I'm saying, no, that's not the problem. Even if you haven't run out, other people have. And your customers won't be able to talk to people who only have IPv6 unless you also implement IPv6. Okay, so here's what will happen. There are devices called carrier-grade network address translators. These are huge boxes that take the IPv4 address space in the routable world and translate it into private IP address space like network 10. And to make matters worse, in order to provide enough IPv4 address space to everybody, you cascade these network address translation boxes like this. Horrible idea, very fragile, messes up end-to-end security and cryptography and everything else. So it's a terrible idea. We're probably going to have to do some of it anyway in order to get to the point where we've all implemented IPv6. And if we really have everyone up on IPv6, then we don't need network address translation and we don't need IPv4. But we have to build a scaffolding like stepping stones across a river or a brook.
Okay.
And so sometimes the NAT boxes will be those stepping stones, but we don't want them to be there for any longer than they have to be.